Well, I'm back to the arcade. Well, in the last video, we fixed the first pattern board. In this video, we're going to attempt to fix pattern board number 2. Now, maybe we got lucky on that first board. It went a lot smoother than I thought it was going to go. And like I say, I've always heard they're hard to work on. And it wasn't easy, but it turned out, like I say, a little bit better than I thought it would. But that may have been an exception to the rule. Now, the other 2 pattern boards, the one I'm going to work on next, the last time I tested it in the game, the game would boot up and run, but it had like a red rug pattern over top of the game graphics. You could see the game running in the background, but it just had this red rug pattern over top of it. So, but I haven't tested it lately, so I only tested it in the diagnostic tester. And so we may go ahead and set that up and do that again. But before I do that, I know the third board doesn't boot up at all. The game is just flat dead. So I thought it might be helpful if I wired up sound to my test rig here, so that if the game is working or partially working or running blind, I would be able to hear the sound. So I got the Gorf game board schematic out here, and I got looking at it. And if you look over here, this is the pinout. The game board, or they call it the logic board, or they just call it the Gorf game board. It's the board that has the pins. The one that the harness plugs into. Okay. So I got looking, and Gorf has 2 audio channels. One audio channel is for the sound, and one is for the speech. So if we look at the pins here, on the J2, which is the 28-pin connector on the board, pin 1 is audio 1, and pin 2 is audio 2. And if you go down here, pin 3 is the audio return, which is the ground. So you basically have 3 pins, 3 wires. You have a ground that's common to both channels, and then you have audio 1 or channel 1 and audio 2, channel 2. Okay, if we follow these wires here, well, the traces on the schematic, audio 2 is outputted through Q1, which is a 2N4401. And of course, this right here, these 2 transistors, I believe it looks like that's probably like a preamplifier, because Gorf has a separate audio amplifier, and the output of this goes to the input of the audio amplifier. So I would think that this is like a preamplifier. And if we follow it back, it goes up here to the audio output on this X2, which is the custom I/O chip. Okay, so the custom I/O chip outputs the audio, and audio 1 has another set of transistors here, Q2 and Q4, and that's the preamp. And you follow this over here, and that is the output for the SC01, which is the Gorf speech chip. Okay, so the speech is on one channel and the sound is on another channel. I'd have to look at the schematic and refresh my memory, but even though the Gorf amplifier has 2 volume controls and 2 inputs, I don't think it has 2 speakers. I believe, I might be wrong about this, but I believe the audio amplifier merges the 2 outputs into one mono output. I think that's how it is, but I won't swear to it. But it doesn't matter in this application. So what I did is I went ahead and wired up a 3-position plug right here, and I wired in some RCA plugs, and here they are right here. Got a red one and a white one. One's for channel 1, one's for channel 2, and I just plugged it directly into my little DVD player, which I'm using as the monitor, because this has, you know, the stereo input. So I figured, hey, if this is outputting line output, it should go into this input with no problem. So it just simplified my audio setup. As I was thinking about getting a set of like computer speakers and wiring all that stuff up, and I got to thinking, I said, I already got the amplifier built into the monitor here, so why not use it? So that's what it did. So let me flip it on. And we should have audio. And there we go. So I now have sound output on my little test rig here. So I think that'll be probably helpful. Also, when I'm probing around on the board, a lot of times when you probing something, it'll still affect the sound. So you'll be able to hear you know, if I use the Logic Pulsar or whatever, you might be able to hear a sound or two and you know, tell that, okay, it's affecting that chip one way or the other. So anyway, okay, now we got that out the way. Now let's go ahead and test the board that we're going to try to fix and see if we can figure out what it's doing and what it's not doing. Okay, well, put on the next pattern board we're going to be working on. This is board number 11, and I labeled it as bad. And this board is the one that I had down as the game runs, but it had the rug pattern over top of it. So let's turn it on and see if it does anything. Okay. I hear a little pattern in the sound, but yes, it's doing nothing. Okay, I think what I'm going to do is, since this isn't doing what it did the last time I tested it in the game, let me go ahead and pull this setup apart, and I'm going to put the Bally Midway test boards back in here, and I'm going to set it up for the pattern board test, and we're going to do the pattern board test and just see what it comes up with. And we know what it came up with back when we did it, when we were testing the test boards. Well, let's go ahead and do it again and see what we come up with. Okay, we got the pattern board tester back in. So let's first test the board that we just fixed, because we know we just had that working. All right, let's go ahead and fire it up and see what we get. All right, it says looks good. So that means this board is working, and of course we know this board is working. Okay. Now let's put in our next board. And let's see what this one says. Okay. Well, I believe this one looks like it's telling us the same thing it did the last time we tested it when we were doing the pattern board test card test. And the data bus says is okay, the linear is okay, the area is okay, but we have a bad X wide. Feedback is okay, the status is bad, and down at the status, the flop is bad, the flip is bad, the flash is bad, the cons is bad, the EXP is bad, but the DIR is okay. All right, well, we're going to find out that if any of this holds true, because in our last test, the board that we just fixed, it told us that the status was bad and the flip was bad. And we changed U21, which is the status chip, and we know that didn't work. But I did kind of trace back that pin 12, which is the flip. It did kind of go down to the feedback area to where the chip that was actually causing the problem, U38, is in the feedback section, even though it didn't, it said the feedback was okay. And of course it has a test here for the feedback, which says the feedback in this one is okay, and the last test it was okay. So how much stock can you put in this card tester? Well, the RAM board tester works fine. But so far the pattern board test hasn't shown me much, but maybe it can redeem itself this time, because all right, it says the status is bad. All right, well, I think the first thing I'm going to do is probably change U21 like I did on the other board. That will just eliminate the status chip altogether. And it says that everything on the status chip is bad except for the DIR, which I think is the direction, I believe. So, yeah, well, we'll start with that. I might do a little probing with the logic probe and, you know, kind of see if it, you know, looks, I can use my test footage that I made from the last one. I can make another test footage and see if that chip is doing anything different. Of course, the program's not running, obviously, so I'm sure it's probably not working. So, but maybe we'll have some signals that aren't there, or stuck high, stuck low, or whatever. We'll just have to probe into it and see what we can find out. So let's go ahead and get started. Okay, well, it's been several days, so let me see if I can get you caught up on what I've been doing with this pattern board. I went ahead and decided to go on the recommendations again of the Valley Midway pattern board test card. And the test card told us that there was a problem with U21, and it also told us there was a problem with the X-wide circuit. So I thought, well, let's start with U21, so that's what I did with the last board. And the first board, in the other video, we found out that it was nothing wrong with U21. So anyway, I went ahead and I put the bad board in, and I tested it, all the pins, with a logic probe. Then I put the good board in, I tested it with a logic probe. There was some differences in some of the pins. So I said, well, let me go ahead and we'll change U21. So I did. I pulled it out and I put the chip in my chip tester there. U21 tested good. So I went ahead and put a socket in and put a new chip in anyway. So now we know U21 is not the problem. Okay, so then I turned my attention to the X-wide circuit, which is the other thing that the test card said had a problem. So I went ahead and on the sheet right here, the X-wide, it tells you the location of the chips in the X-wide circuit to check. So we got U31, U32, U33, U40, U41, and U42. Okay, so that's six different chips. So what I did was I drew up a little quick chart by hand here, and I labeled it X-wide, and I put each chip down. I started with U31, and I made 2 columns. All these chips are 16-pin chips. So I labeled each column 1 through 16, and I started out with the bad board, the board that's in there right now, and I used my logic probe, and I probed on each one of the pins. And I wrote down, because this board's not working, what I did was I had the board cut off. I put my logic probe. I started with pin 1 of U31, which U31 is right here. So I put my logic probe on U31. Then I flipped it on, and then I looked at the logic probe and to see what it would do, whether I got a high pulse or high, a low, or a pulse, or a combination of whatever. So then I just wrote it down. So like pin 1, I put LP because it had a low pulse. Pin 2 was just low. Pin 3 was a high-low pulse, and so on and so on. Okay, I did that for all the chips, okay, on the bad board. Then I put the good board in, and I did the same thing. Now, because the good board is working and it runs in a continuous attract mode, what I did was I wanted to see what the logic probe was doing at power up, which is the same thing I did with the bad board, because both boards are going to start out the same way, okay, when you power it up. So I figured that if I took the good board and every time I took a reading on a pin, I would cut the power on and write down within the first few seconds of what the logic probe was putting out. So I did that for all the chips, okay? I wrote them all down. Once I did that, I could do a comparison. So on the bad board, pin 1 had a low pulse. On the good board, it had a low pulse on pin 1. So I put a little green mark beside both of them because it had the same reading. Pin 2 was low. Pin 2 was low on the good board, so I put a green dot by it. And I did this all the way down. Now, I put a yellow dot here because pin 6 was different than pin 6 on the good board, okay? Come to find out, once I did a little more research, I put a NA right here in blue. Anywhere you see a NA, that means that that pin on the board is not connected to anything. So pin 6 is not used anywhere on the board. Okay, so that's what that NA means, not applicable. So when you see that, that's what is there. So I continued with looking at it pin by pin, and everything else matched up on U31 just fine. So then I went to U32 and I did the same thing, and here is where I started getting some discrepancies. Okay, so if we look at the data sheet here for U32, And we're looking at pins 2, 7, and 10. All right, U32 is the MC14175B. All right, so if we're looking at pins 2, pin 7, and pin 10, all of these are Q. Q0, Q1, and Q2, okay? If we look over here, Q is an output, okay? So that means the signal is bad here, so this is the output of this chip. So the output must be bad, right? Same thing with this chip. This chip is the same chip, U41. It's also a 175. And this one's got both all 2, 7, 10, and 15. They're all reading bad. So that's the output. Now, over here, these two chips, 33 and 42, U33 and 42 are MC14516B, okay? And we got 4, 12, 13, and 3. All right, so here's 3, 4, 12, and 13. They're both labeled as P. P3, P0, P2, and P1. All right, P equals, I got it on the data sheet here. P0, P1, P2, and P3 are preset inputs. So this is outputs and this are inputs. So I would say that this chip is bad and this chip is bad because I got bad outputs going to the inputs. On the good board, I got the same signal coming out the outputs and going into the inputs. But on the bad board, I got the same bad outputs going to the inputs. So what I'm going to do next is I'm going to go ahead. I already tried piggybacking these chips. Didn't do anything. The piggyback thing doesn't always work. So I'm going to go ahead and I'm going to change both U32 and U41. And we'll find out what happens after that. All right, well, I done pulled both of these chips out, both U32 and U41, and I tested them in my tester here. And unfortunately, they test good. I don't know now. I could have swore they were going to be bad. But the tester tests both of them as good. So, can it be that since these two chips that I thought were bad are good, something is causing these signals not to be right? Could it be that these chips, that the input is shorting them out or something? I guess since I'm in this far, I'll go ahead and I'll remove 42 and 33 and check them with the tester and see what they are. And if they come out good, then I'm just lost. I'll have to regroup and start all over again. So let me get one of those out and test it, and I'll be right back. Well, I really thought I had something going there, but I can't figure it out. I'm back to the drawing board. I replaced U33, U32, U42, and U41. It's doing the exact same thing. So I don't understand what is causing it. I don't know. Back to the drawing board. Okay, well, it's been a while. I had to regroup after I thought I found a problem, and I wound up replacing a total of 5 chips. I replaced U21 to start with, found out that there's nothing wrong with U21, and then I replaced U32, U33, U41, and U42. I thought they were bad, but turns out they're not bad. They were good. So I had to regroup and rethink this thing out. So what I decided to do, and I come up with, I decided to test every single chip on the board, okay, with the logic probe. And what I did, I made up these charts, and most of the chips are 16 pin, but there are a few LS chips that are 14 pin. So anyway, I have 1 through 16 here, and this is like U12 right here, and this is the bad board. So I tested the bad board, and I did 6 chips at a time, and then after I did the bad board, then I put the good board back in, and then I would check each pin, and I would write down what the logic probe was telling me. You know, if the pin had a high-low pulse, all 3 LEDs are pulsing or lighting, then that's what I would write down on the chart. And if it had only the low came on, I would put down the L for low. If only the highlight came on, I'd put an H, and so on. So I did that for every single chip on the board. Now I'm down to my last 6 ICs to be checking. So I thought before I finished up, I have 1 left, U43. Turns out to be the last one. Now U43 is only used 2 pins on the chip, on the schematic right here. Pin 8 and pin 9 are the only 2 pins on that chip. So when I tested the good board, pin 1 was floating or dead, and quite a few of them are floating dead, and the rest are low except for pin 8 and pin 9. They both had a high-low pulse on both 8 and 9. So now I'm going to go ahead and test that chip on the bad board. And when I get all these together, what I'm doing is I'm going through, and if the good board has a signal that's the same, like right up here on U12, pin 1. The good board on pin 1 had a high-low pulse. Pin 1 on the bad board also had a high-low pulse. So the signal is the same on the good board and the bad board. So in that case, I would go to the schematic, and I would put a green dot on that pin, because that pin was the same on the bad board and the good board. This is my logic. Now, whether, you know, I don't know if this is going to work or not, but this is just my way of thinking. If a pin is different, if I get one reading on the good board and a different reading on the bad board, then that pin number on the chip will get a yellow dot, okay? So anywhere on the schematic, if you got a green dot, that means the signal is the same on the good working board and the bad board. But if you got a yellow one, well, that's a problem area. Now, it may be that all these yellow dots are because this section of the board isn't being enabled, okay? Maybe the enable pin on that particular chip is not getting the proper signal from somewhere else on on the board or on the schematic here. So what I'm going to try to do is when I get all these logged in on the schematic, I'm going to look over the schematic and try to figure out where the problem area is. Okay, if that makes sense. So I just thought I'd go through this last check, the last IC with you. And I got to do pins 1 through 14 on U43, which is a 74LS04. So let me go ahead and set up and I'll just show you how I do it. Okay, now because the bad board, the program isn't running, but the good board, the program is running. So what I decided to do is, how do you try to get the same reading? Because if you probing the good board while it's in another section of the attract mode, the pins are going to be doing different things, so you're not going to get a consistent reading. So I figured that if I check the pins at power up, so I say I take, like we're doing U43 pin 1, so I put it on pin 1 U43 and then I turn the power on and I take the reading within the first couple seconds, because both boards are booting up and hopefully they're booting up the same until they run into the problem. So I'm trying to get a snapshot of what the chips are doing between the good board and the bad board at the same time, if that kind of makes sense. So with that said, I'll put it on pin 1, turn power on, and nothing. That pin is, I guess, floating because I'm getting nothing. It's completely dead. So I go here and I put floating. Dead. And if you look here, you'll see on the good board that was identical. It was floating and dead. So far so good. We're getting the same reading. All right, so let's do pin number 2 on U43. Okay, we're getting a low. And I usually do this at least 3 times, and if I get the same reading 3 times, now sometimes you don't quite get the same reading. You might get a low then a high, or you might go straight to a high, or you could go to a high pulse. So I usually try to do it at least 3 times. If I get 3 consistent readings, then that's the one I go with. So pin 2 is reading low. All right, so I go back to my paper here and I put down low, an L for low, and on the good chip we also had a low. So far it's identical. All right, let's go to pin 3, do the same thing, power on, it's dead. Okay, all right, pin 4. Getting a consistent low on pin 4. So let's go down here, and pin 3 was floating. Dead, and then pin 4 was low. And we're still getting identical readings. So far this chip is behaving the same on the good board and the bad board. Okay, you get an idea. I'm going to go through the rest of these pins and then I'll come back and show you what I found. Okay, well I finished up U43, which is the 74LS04, and so what I'll do now, I'll come back and we'll look at pin 1 of the good board and the bad board, and we say it's the same. So if it's identical, I'll put a green dot beside it. Pin 2 is identical, that gets a green dot. Pin 3 is identical, green dot. 4 is identical. 5 is identical. 6 is identical. 7 the same. 8 the same. 9 the same. 10. 11. pin 12, 13, 14, and it's only a 14 pin chip. So U43 are identical between the good board and the bad board. So we can pretty much say that U43 is good. So that's kind of how I'm trying to weed out the good from the bad. Now, doesn't always work out this way, but like I say, this ought to, in theory anyway, point me towards the bad chip. So let's go through a couple more of these just to show you what I'm doing. Here's U12, which is the 74LS00. Okay, so we know the good board, they're all 14 pins are good. So I got green dots on them because I've already checked those. Okay, so pin 1 is the same, so that gets a green dot. Pin 2 is the same, high-low pulse. All right, pin 3 is a high-low pulse, that's the same. Pin 4 is a high-low pulse, that's the same. Pin 5 was reading a little bit different. It was reading, I got a pulse and then a high-low pulse, where a good board was reading high-low pulse. So sometimes you get a little variance in there. This may very well be the same, identical, but because it's not 100% identical, I'm going to give it a green dot, but I'm also going to give it a yellow dot to let me know that, hey, maybe it's a problem, maybe it's not a problem. Okay, I'm thinking that it's not a problem. I'm thinking it's just a little abnormality to the reading. But like I say, it could be a problem and it might not be, but we're going to document it anyway. All right, pin 6 is high-low pulse on both, so that gets a green dot. Pin 7 is low. I think that's the ground on the chip. Pin 8 is a high-low pulse. That's the same. 9 is a high-low pulse. That's the same. Pin 10 is a high-low pulse. That's the same. Okay, here's where we do have a difference. Pin 11. The bad board is just reading a high, okay? But the good board was reading a high, low pulse, and then a high-low pulse. So the red LED on the probe would come on red. And that's why I got a hyphen between the high and the low. The red would come on first, then the low pulse would come on, and then all three would start pulsing, high-low pulse. So that's why I got a high hyphen, low pulse, high-low pulse. So these are definitely different. So pin 11 is going to get a yellow dot. Okay. All right. Pin 12, the good board had a low hyphen high, where the bad board just had a low. Okay. Now they both start out with low, but this one goes to high and this one stays low. So that's a red flag. I'm going to mark that down as yellow. Pin 13, they're both high-low pulse. So that one gets an okay, green. And 14, well, that's the VCC, the power pin. So that's both high, so we know that's good. Okay, so that's basically what I'm going to do. I'm going to do the rest of these, and then I'm going to come back and I'm going to show you how I transfer this to the schematic. Okay, I'm going to try to show you how I do this on the schematic now. It's a little difficult to try to get it set up, but I think I can show you here on this one. Now we're going to do U12, okay, which is a 74LS00. Now here's U12 here, U12 here, U12 here, and U12 right here. So U12 is at least 4 places on here. I don't know. I think that's all of it. Because usually every pin is not used on a lot of these chips. There's usually 2, sometimes 3 that's not used on most of them, or a lot of them. I won't say most of them, but quite a few of them. Okay, so let's start with pin 1. Pin 1 and U12, we had the good board and the bad board had the same signal. Okay, so that's going to be a green. So where is pin 1? Pin 1 is right here. So what I do is I just take and put a little green dot right there where pin 1 is. So I know the signal there is good on both boards, the good and the bad. All right, pin 2, that's a good signal on both boards. I think that's pin 2, but that's a little hard to read. So I got my original schematics here, which are much better. So I'm going to look at that. And yes, that is pin 2. So pin 2 is right here. So I'll put a little dot right there by pin 2, green dot. All right, pin 3 is the same on the good and bad board. So that gets a green dot. So here's pin 3. So I'll put a dot right there. So this part of U12 is working correctly. So this part of the circuit, I don't know what if that's a AND gate or gate or whatever. If I have to, I'll look it up and I'll be able to, do the truth table and see what the signal should be. Maybe they're not all supposed to be a high-low pulse, because that's what they are. Pin 1 is a high-low pulse, pin 2 is a high-low pulse, and pin 3 is a high-low pulse. So I might have to come back and look and see if that particular gate is working correctly. Maybe if 2 of them are high-low, maybe one of them is supposed to be low, or maybe, this one, well, anyway, I'm not going to worry about that right now. Right now, I'm looking at it as it's good because it was the same on both boards. That's the key right here to it, that if it's the same as both boards, same signal, then it should be good and working properly. That's what I'm going on, okay? So let's do pin 4 now. Where's pin 4 is down here on this one. Pin 4, they're both high-low pulse, so that gets a green. All right. Now pin 5, that's kind of in question because on the bad board I had a pulse and then a high-low pulse. On the good board I just had a high-low pulse. So I kind of put a question mark on that, but I'm leaning towards that being good. So I'm going to put a green dot by it, but I will put a little yellow dot underneath it, just as a reminder in case that circuit comes up as it might be a problem. But I'm thinking it's good, but we'll go with that right now. All right, pin 6 is good, high-low pulse. So here's pin 6. And that's another reason why I think it's good, because it's identical to this one up here. All 3 of those were good. So I'm thinking all 3 of these are probably good too. And another way you can tell, like pin 5, that was the one in question. If we follow this over and up to U5, U5 was good, and these 2 are tied together. So that's another way of eliminating that as a problem. So I should have looked at that first, because if it was good on this U5, and it was because I got a green dot there, then that's probably good. So, that's my way of thinking anyway. Okay, so we're up to pin 6. So pin 7, that's the ground for the chip. Pin 8. I don't see a pin 8. This is the only other U12 that I see. Let me look the board over the schematic over real quick and see if I can find another U12. It could be another one. Yeah, down here. Yeah, that's on camera, just barely. Okay, that looks like 8. That's 9 and that's 10. So let me look at my good schematic and make sure that's 8, but I think it is. Yes, it is. All right. All right, pin 8. They both had a high-low pulse, so that's good. So pin 8 gets a green dot. And that's good because U6 right here is connected to U6, and that got a green dot. So we're pretty confident that that is good. All right, now pin 9. Also, we had a high-low pulse on the good and the bad board. So pin 9 gets a green dot. Pin 10 had a high-low pulse on both, so that gets a green dot. So, U12 looks like that's good, this part of U12. If we follow pin 9, which has a green dot, up here to U14 to pin 13, that had a green dot. So we're pretty sure that that signal is getting to U14 or U14 is getting to U12. I don't know which is which. I think the way it's set up, it looks like the signal from U14 is going into U12 and then coming out of U12 into U6. If I'm reading this right, and I'm not sure, and then U6 pin 10 goes out and goes up here to pin 1 of U5 and also goes over to pin 5 of U12 over here. And then 6 of U12 goes around down through here, and I haven't got to that chip yet, so we don't know about that yet. Okay, where was I? Pin 10 of U12. All right, now here's where it gets to be a problem. Pin 11. U12 pin 11. That's 10. Okay, up here. All right, pin 11 on the bad board was a high, but on the good board it was a high, low pulse, high, low pulse. So that's not correct. So pin 11 gets a yellow mark. So that's not good. Pin 12 of U12. On the good board it had a low dash high pulse, but on the bad board it just had a low. So that's bad. So pin 12 gets a yellow dot. And let's see, pin 13 has a high-low pulse on both the good board and the bad board. So pin 13 is good. Okay. So, because this part of U12 and this part of U12 and this part of U12 and this part of U12, they all look like the same type gate. And these are all the same, but this one has 2 pins that's different. So something is different there, whether that's right or not. Pin 12 goes to U21, and we know U21 is good. So, but something could be sending the wrong signal to U21. Although everything else on U21, except for these, I don't know if these are inputs or outputs. So that's an area we're going to have to investigate. I don't know which way the signal goes there. But something, doesn't look right there. Okay. 13, 14. I don't think there's a pin 14 for U12. Evidently that pin's not used unless I find another U12 somewhere, and I don't think there is. So, okay. So that's what I'm going to do. I just wanted to kind of show you how I'm doing the schematic and the madness behind it. Some of you might be saying, what in the heck is he trying to do? Well, I'm trying to create, I guess you could say, an electronic roadmap. And by marking it all out on the schematic, you can look at it and try to tell where the traffic jam is. Okay? Does that make sense? Okay. I'm going to go ahead and shut it down for now, and I'm going to go ahead and put the information in for the rest of these chips, and then I'm going to look at any discrepancies and double check and see if I need to make any corrections anywhere, and then I'll come back and we'll see if we can't figure out an area on the schematic that we can see a clear problem. And then if we have to, we'll get the data sheets out for the chips and try to determine what the heck is exactly going on. I mean, like these areas up here, we know I replaced these 4 chips right here, and these 2 chips here in the X wide section. These are pretty, I'm pretty sure these are good because all the signals got green dots on them. I've already checked the pinout on these. But these wouldn't. So something is awry here, even though we know the chips are good. So it has to be some signal that is causing this. A lack of a signal or a wrong signal. And hopefully we're going to be able to find, because even though these are like separate sections, they're all kind of tied in together. So, like, I'm suspecting U3 up here to be bad because all 3 pins on this section of U3 are yellow. Okay, well, we got U3 up here, and we also got U3 way down here. Here's another section of U3 right here. But this section, all 3 pins on U3 are green. And here's another section of U3. Both of these are green. But this section up here, they're all yellow. So this is the chip that right now I'm suspecting is bad. And this is the chip that I don't have in my stock. So I got them on order. Today is Friday. They're supposed to be here Monday if the U.S. Postal Service estimate is correct. So we're going to have to wait till Monday before we can do anything about that. First thing I'll probably do is, when I get it, is piggyback that chip and see what happens. So, all right. Let me go ahead and finish this off, and then we'll come back and take a quick look at it and see if we can find any other areas besides this area right here where I think things are going awry.